Hey everyone, and welcome to The Explainer. I'm going to be your professor today as we really dig into the fascinating mechanics, the hard data, and the absolute stunning visual realities of sustainable architecture. Today, we're basically upgrading our understanding of what it truly means to build for the future.
So, here's our lecture syllabus for today. We'll start by defining the green building. Then we'll cover the core principles of sustainability, break down the anatomy of eco-friendly construction, explore some global and Indian architectural marvels, and wrap up with the future of construction.
All right, Section 1, defining the green building. Let's establish exactly what we're talking about here.
Because, a true green building is definitely not just about throwing a few potted plants on a roof and calling it a day. As our definition points out, it's a rigorous, mathematically measurable reduction in environmental impact. It's about actively decreasing our heavy reliance on the traditional power grid and commercial logging, and instead completely shifting toward operating in real harmony with the natural environment.
That brings us right into Section 2, the core principles of sustainability. Let's look at the foundational pillars.
There were 6 core components to this whole concept. We're talking strict energy and water demand reduction, prioritizing low-energy building materials, minimizing waste, optimizing indoor air quality, and overall environmental harmony. Now, the absolutely crucial takeaway here is that these 6 things can't just exist in isolation. They literally have to work together synergistically to achieve true architectural sustainability.
Okay, moving on to Section 3, the anatomy of eco-friendly construction. Let's see how this translates to bricks, mortar, and glass.
To really wrap our heads around this, let's look at the data coming out of Seattle. This is a city that set a wildly impressive academic standard with 32 formally recognized green buildings. These structures serve as the perfect real-world model for us to break down.
If we map out the first 3 steps from Seattle's blueprint, the mechanics of sustainability become crystal clear. Think of it like a giant puzzle. Roof-mounted wind turbines and solar panels generate independent power. Meanwhile, you've got operable vents precisely circulating air and double-pane skylights providing brilliant natural lighting and vital thermal insulation, all without taxing a centralized heating system.
And this part right here brilliantly illustrates the dual approach to resource management. We're capturing natural elements from above using a thin layer of plants and soil on the roof, which is amazing for insulation, absorbing stormwater, and literally creating oxygen. Simultaneously, down below ground, cisterns collect rainwater for landscaping, while composting toilets dramatically slash freshwater usage. It's a completely closed-loop engineering system.
Now for the really fun part. Section 4, global and Indian architectural marvels. Let's see these principles in action.
The Suzlon Energy Building in Pune is a phenomenal visual demonstration of those earlier principles. The exterior completely integrates expansive water features that naturally cool the surrounding air, and then inside, there's this massive glass cylinder that allows pure, unadulterated sunlight to just flood the interior, drastically cutting down the need for any artificial daytime lighting. Let's crunch some numbers. The hard data from the ITC Royal Gardenia in Bengaluru is mind-blowing. Check out that distribution. A whopping 57% of its roof area is entirely dedicated to a living, breathing green space. This is a clear case of ecology dictating architecture, not the other way around.
And get this, by integrating all these systems, that exact same building hit a staggering 100% reduction in potable water usage for its landscaping. How? They engineered a system that exclusively utilizes treated wastewater. Literally 0 fresh drinking water is wasted on watering the grass. If we hop over to an IT company in Fukuoka, Japan, we see urban integration taken to the absolute extreme. The cascading, stepped green roofs literally transform this commercial structure into an artificial, oxygen-producing mountain right in the middle of a dense concrete grid. It's just incredible. But what about harsher, more extreme climates? Well, high up in Ladakh, we find the Druk White Lotus School. Instead of shipping in modern carbon-heavy materials, they used local stone and certified sustainably harvested timber. This protects regional forests while giving the building massive thermal mass. That's the ability to absorb and store heat energy, which is absolutely essential for withstanding the freezing Himalayan elements.
When you step inside one of their classrooms, you really have to pay attention to the architectural orientation. The building's actual placement ensures maximum natural lighting throughout the day. It creates this optimal, low-energy learning environment that naturally keeps the students warm and focused.
And crowning this entire structural masterpiece is an incredible circular solar roof array. This specific feature mathematically proves that even the most remote, grid-disconnected locations on Earth can completely and reliably sustain their own energy demands. Of course, it requires some serious upfront engineering and battery storage infrastructure, but it's entirely possible. Heading back into urban centers, we see how these huge central voids are utilized, whether it's the octagonal side-lit atrium of the ITC Green Center in Gurgaon, giving off this perfect glare-free light, or the literal indoor waterfall at the Punjab Forest Complex in Mohali. These cavernous interior spaces are highly calculated engineering choices for air quality and thermal regulation.
Take the Institute for Rural Research and Development in Gurgaon. It perfectly encapsulates our earlier theories with pure, hard numbers. It mathematically eliminates its water runoff down to zero. Concurrently, its rooftop array generates 35 kilowatts peak of solar power, meaning it maximizes its output during those peak sunlight hours. This right here is the very definition of a net positive environmental impact.
Now, you might be thinking this only works for smaller offices or boutique schools. No way! Even massive infrastructural hubs, like the Rajiv Gandhi International Airport, apply these exact precise landscaping, daylighting, and energy principles. They have to do this to offset the inherently massive carbon footprints that come with global aviation.
Finally, Section 5, the future of construction. So, where do we go from here?
Well, as we see buildings that literally loop seamlessly right into the forest floor through continuous circular designs, the visual and ecological distinction between nature and man-made structures is rapidly disappearing. We are no longer just building on the environment, we are finally building with it.
So I'm going to leave you with this. Knowing the strict anatomical mechanics and the brilliant realities of sustainable design that we've unpacked today, how are you going to evaluate the ecological footprint of the next building you walk into? Class dismissed. Thank you so much for joining this explainer, and remember to always keep questioning the world built around you.